So today's the last lecture. After this, I will summarize. Actually, the last topic on ductile yield is not difficult at all. It's pretty straightforward. Okay. So where we started, we solved this problem where right? So we want to find we know our stress Y. Let's go back to the problem. We're going to determine what is the magnitude of the torque that is allowable. Okay, so what is allowable? So as always, like what we have seen in Vomisis and Tresca, we always sketch the 3D mole circle so that we can determine what is our stress A and what is our stress B. So we can determine our normal stress about Y, okay? Unfortunately, we cannot get our shear XY because we don't know our torque. Okay, I repeat again, we don't know our torque. Okay, so I'm going to copy this whole thing. We're going to continue from here. Let me zoom out. Bear with me. Right. So we don't know our torque. We cannot find our shear XY at all. Okay. However, we are going to use Vomisis criteria. Okay. Do not shake those cans and start opening. Okay. So we have stress A. So where are we now? We're going to determine stress A, stress B, where this eventually will be equal to stress average, normal stress average, plus or minus the radius, right? So why this is so, if you look at this mole circle over here, we know that, right? So what we know is, I'm going to draw our stress average line. So this is sketch. Over here, so this is our stress average line, right? So the next thing we want to acquire is we want to acquire what is our radius. Okay. Right? We don't know what is our radius, and this formula tells us how to find stress A and stress B. So now if we were to focus onto Vomisis criteria, right? We are going to go into Vomisis. So based on Vomisis criteria, or I'll put here that R is the radius or tau max, okay, for the 3D mole circle. So from here, when we substitute into Vomisis criteria, now you have to remember Vomisis criteria, okay? I'm not going to, this will not be in the formula sheet. So it's basically stress A squared minus by stress A, normal stress B, plus by stress B squared. And we know that it has to be smaller than the stress U squared. So this is the formula. So we are going to let stress A is equal to stress average plus R. And we're going to let stress B is equal to stress average minus R. Okay. So from here, we're going to substitute into equation number 1. Okay, we're going to substitute into equation 1, right? So I'll put that you have to remember this. I forgot to put into the formula sheet. So from here on, we just put stress A or stress average plus by radius squared. Then we minus by stress average minus R or plus R. And then stress average minus R. And then we have stress average minus R squared. Okay, and then we know that the whole thing has to be less than stress U squared. So I'm going to expand or get rid of the brackets, and then you can see a simplified version of this equation, okay? And it does not look so bad. So stress average squared minus 2R stress average plus by R squared minus by stress average squared, and then 1 times so minus R squared. And then we have plus stress average squared. I think this one is minus 2R stress average plus by stress average or plus by R squared. So you realize that we can cancel a few terms, right? So we can, so the first one is plus, I'm sorry, okay? So we can get rid of this term over here. We can get rid of this term over here, right? So we realize that we also can get rid of this stress average because plus minus, okay? Anything else where we can get rid of? I don't think so. We can get rid of anything else. So finally, we come up with an expression where we have stress average squared 1 minus minus plus plus by 3R squared. Okay. And then I'm going to change the term over here to be equal to the stress U squared. So when we do this, this is our equation number 2. So to objective is to what? Determine R. Okay. So our objective is to determine R. So from here on, I'll go to the next page. So we're going to determine R. So we just need to rearrange this equation. So R will be equal to square root stress U squared, right? And then minus by stress average squared. And then the whole thing divided by 3. So all these values we have, right? Did we determine stress average before? Let me see. Nope, not yet. We can determine stress average, right? So stress average is basically stress X plus stress Y divided by 2. So first, we're going to determine stress average. So this happened to be equal to minus 33.953. And stand about 3 divided by 2. So 33. Giving you guys the beer is a load off my shoulder. Trust me. Okay. I was feeling so bad today, but anyway. 16.977 times by 10 to the power 3 psi over. So this is your stress average. Okay. Yes. So it was what we have done earlier or yesterday. We know that we have a stress Y value, right? It was done yesterday, and we know stress X is equal to 0. So we know our stress average now, we know our yield, so the radius will be equal to what? Will be equal to your will be equal to the tongue tight. Will be equal to your yield, which is 42 times 10 to the power 3 squared, minus by minus 16.977 times 10 to the power 3 squared, and then the whole thing divided by 2. Okay. So from here, 42 power 3 squared minus 16.977 power 3 squared divided by 2, square root of the whole thing is 27.164. Times 10 to the power 3 psi. Yes, sir. Oh, where? Yeah. Thank you. I ran out of beer. I ran out of beer. So 42 power 3 squared, 42 power 3 squared minus 16.977 power 3 squared divided by 3, square root of the whole thing is 22. Yeah, 22.179. Thank you. Matthew, I'll buy you shawarma, okay? So that's our radius. So what we're trying to determine down here, if we look back, we have to find, okay? We have to find LXY, okay? We have to determine the shear XY. Why we need to determine our shear XY? Because we have to find shear XY, then we can substitute into shear XY is equal to TR over what? Over J. With this, then we can determine the what? Then we can determine the torque. Because it's the torque that we have not a what? That we have not a clue. Okay. So now when we go back to the circle, I'm going to copy and paste the circle, no worries. So where we are now, it's not complicated, okay? We know our radius, right? We also know our stress average. The next thing we are going to determine is we are going to determine our what? Determine our shear XY. Okay, we are going to determine our shear XY from here. Does that make sense? So that's the flow. So from here to determine shear XY, don't memorize any of those formulas that you see in the textbook. It's absolutely not worth it. Okay, just focus on the circle. So we know that shear XY will be equal to what? Will be equal to R squared minus by what? Stress average what? Squared. Yes or no? Right? So we know our R squared will be equal to what? 22.179. Right? Then let me write better. 22.179 times 10 to the power 3 squared minus by the stress average, which is equal to 16.977. Okay. So this will be equal to 22.179 power 3 squared. Okay. Square root. So you get 14.272 times 10 to the power 3 psi. Okay. So now we can use this formula to find torque. So we know that shear xy is also equal to TR over J. The shear xy is equal to 14.272 times 10 to the power 3. Then we are going to find torque. Our radius, I'm just going to call R, or R radius. I'm just going to call R for now because J is equal to pi over 2 multiplied by R to the power 4. Okay. So knowing this, we can cancel the radius. They cancel once. Cube. So your torque will be equal to 14.272 times 10 to the power 3 multiplied by pi over 2, and then multiplied by the radius is equal to 1.5 divided by 2 cube. Okay. So 1.5 divided by 2 power 3 times by shift pi divided by 2 times 14.272 power 3 is equal to 9.458